Hi everyone, it's Math with AUB. In the name of the Lord, the most merciful, the beneficent, we have already embarked upon the journey how to find out the domain of the real valued functions. I have repeated several times once more that we have to take care of three things while dealing with the questions on domain. How to find domain? Number one, log is defined for positive values. In square root, we cannot afford the negative values, and overall denominator never ever be 0. Denominator never ever be 0. Exclude all the values, discard all the values where denominator is 0, discard all the values where log is negative are 0, and square root cannot be overall negative because it is complex valued function rather than a real valued function. Our question number 11 goes as: the domain of the definition of function comprises two parts. One is 1 over log of 1 minus x at the base 10 plus x plus 2, x plus 2. Dealing one by one, taking first part, we have log of 10 minus log of 10, log of 1 minus x at the base 10, log of 1 minus x at the base 10. It is defined for positive values. 1 minus x is greater than 0 or 1 is greater than x. Writing this inequality in that fashion, 1 is greater than x or x is less than 1, both are same. It means that's our origin. 1, 2, minus 1, minus 2, x less than 1, less than 1, less than or equal to, equal is not mentioned, so 1 is excluded. Taking only x less than 1, x less than 1 means the left hand side of the 1, left hand side of the 1. All these values qualify for this log 1 minus x, 1 minus x. What about the other part? Other part is root x plus 2. It is defined for positive values. It must be greater than or equal to 0. Equal to 0 means our overall square root is in numerator. We can afford 0 in the numerator. So x is greater than or equal to minus 2. X is greater than or equal to minus 2. Graphing the domain for this, x is greater than 2. Greater than 2 means log 2, shed 2, minus 2. It is included. It is included. It is included. Greater than or equal to minus 2. We have to travel towards right. Towards right. That is the common portion. That is the common portion. That is the common portion is our domain. Our domain is from minus 2 to 1. Minus 2 to 1. Minus 2 to 1. Now we have to check whether there are some values where log is meaningless or square root is meaningless. We have to take care of this thing. We have to take care of this thing. If I plug in 1 here, if I plug in 1 here, 1 minus 1, it is 0. 1 minus 1, it is 0. Log of 1 minus 1 at the base 10, it will become log of 0, 10. It means 10 raised to what power to get 0? It is not possible. It is not possible. It is absurd. 10 raised to what power to get 0? 10 raised to what power to get 0? It is not possible in real numbers, in mathematics up till now. That's why we have to discard this one. We have already discarded. I am giving you the reason. What about 0? What about 0? If I plug in 0 here, so I have log of 1 minus 0 at the base 10. It will become log of 10, log of 1 at the base 10. It means 10 raised to what power? 10 raised to what power to get 1? It is obviously 0. 10 raised 0 is equal to 1. 10 raised is 0. 10 raised 0 is equal to 1. But this our overall quantity lies in the denominator. Lies in the denominator. If I write 0 here, 1 minus 0 is 1. It is something 1 over log of 0 at the base 10. Log of 1. Log of 1 at the base 10. Log of 1 at the base 10. Overall result of this quantity is 0. So it will become 1 over 0. 1 over 0. We cannot divide with 0. We cannot divide with 0. We cannot divide with 0. That's why we have to exclude this 1 as well as this 0. This 0 and 1 we have to exclude from the domain. We have to exclude 0 and this 1 from the domain. Let me write in that fashion. Minus 2 is included. Minus 2. The semi-closed interval. 0 is excluded. Write in that fashion. Union 0, 2, 1 is also discarded, 1 is also discarded, open interval. It means that neither 0 nor 1 are the part of our domain. Neither 0 nor the 1 are the part of our domain. So our interval is this one. This is open. Look at this. Parenthesis, the face of this parenthesis must be, in that case, if 0 is included. It is like, it is alternate for this one, -2 to open interval 0, union 0 and 1. Either write small bracket or write this one. They both qualify for the open. They both qualify for the open. They both qualify for the open. So the domain for this overall function that comprises two parts is -2 including, excluding 0, and all the portion between 0 and 1 excluding 0 as well as 1 is our domain of this function. Moving towards next question, we have